Hello children, today I am going to explain another method of balancing the equation, that is oxidation number method. It is very easy but a small bit of confusion is there. I will reveal you that confusion and I will clarify how to balance such type of reactions in this method. So when an equation is given like this, here in the reactant side we have a sulfur, in the product side also we have a sulfur. First I am mapping sulfur to sulfur atom, then I am mapping iodine to iodine atom, right? So after mapping similar atoms in reactants and product side, let us find the oxidation state of the sulfur in reactant side first. Here the oxidation state of sulfur will be +6 and here the oxidation state of sulfur will be -2 and here iodine will be -1 and molecular form it is a 0. So now we have found the oxidation states. Now let us check the change in the oxidation states. So +6 to -2, the change is 8 here, and -1 to 0, the change is 1 here. So after like checking the change in the oxidation state from reactants to product side, what we have to do is we have to multiply the change of iodine with the sulfur and change of sulfur with iodine terms. So I am writing. So iodine change is 1. So I am multiplying with 1, H2SO4, and sulfur change is 8. So I am multiplying 8 Hi. So here also same. So change in iodine should be multiplied with sulfur, that is H2S, and change in the sulfur should be multiplied with iodine. So here I am supposed to multiply with 8, but I am writing multiplying with 4. I will tell you what happened. Sir, iodine term should be multiplied with 8 and sulfur term should be multiplied with 1. No sir, yes. For sulfur terms it was correct only, because here also 1 sulfur, here also 1 sulfur. So that was done. And when you are multiplying here we have 8 iodines. Okay, after multiplying with 8. If you multiply with 8 here, it will become 16 iodines. So you have to multiply with the change, but when you are multiplying, you have to ensure that after multiplication, both sides, the number of atoms should be same. So that is the reason. Here 8 iodines are there. I am not using 8 here. 4 twos are 8 iodines are there. That is the way you have to use. After that, so now you see sulfurs 1 sulfur atoms are balanced. Iodine 8 balanced. Then I am going to oxygens. Here I have 4 oxygens. So this side also I need 4 oxygens. H2SO4 plus 8Hi gives rise to H2S plus 4I2 plus 4H2O. Then I am checking here also 4 oxygens, here also 4 oxygens, oxygens also balanced. Now I am cross checking the hydrogens. 4 twos are 8 hydrogens, here also 8 hydrogens. This is balanced. Understood children? We will do one more. Okay children, I have taken one more example. We will try this. So manganese in the reactants to manganese in the products I have mapped. Chlorine in the reactants to chlorine in the products I have mapped. Now first here what is the oxidation state of the manganese? Here oxidation state of manganese is +4. And here oxidation state of manganese is +2. So here we have +4, here we have +2. The change in the manganese oxidation state from reactants to products is 2. Here chlorine is in -1 oxidation state. In molecular form oxidation state is 0 and the change is 1. So after finding the change in the oxidation, change in the chlorine terms should be multiplied to manganese and change in the manganese term should be multiplied to chlorine. So change in the chlorine terms is 1 only, MnO2 plus. Change in the manganese terms is 2. So I am multiplying to the chlorine. 2HCl gives rise to manganese with 1. So MnCl2. And here is the confusion. Sir, chlorine terms you have to multiply with 2, no sir? Yes. And here sir, you have lived it like this. You didn't multiply y. So after multiplying, we have to ensure that both sides the atom should be same. Again here if I multiply with 2, it will becomes 2 2s are 4 and here only 2. So I am ensuring that here 2. So if I multiply with 2, that will become 4. So I have to ensure that after multiplication, both sides the atom should be same. So I did not multiply it here. Here also 2 chlorines, here also 2 chlorines. I am not talking about this chlorines. We will talk about that chlorines after this step. So here 2 chlorines. So if I multiply with 2, it will become 4. So I didn't multiply it. So now here you see manganese. Now we will check the elements whether balanced or not. So manganese 1 already balanced. Here 2 chlorine atoms. Here 2 plus 2 fluorochlorine atoms are there. This side 2 chlorine atoms are less. So I am repeating the step. MnO2 plus 4HCl gives rise to MnCl2 plus Cl2 plus H2O. After this step, children, let us check. Here we have 1 manganese, here also 1 manganese, done. Here 4 chlorine atoms, 2 plus 2 fluorochlorine atoms, done. Other than oxygen and hydrogen, elements were balanced now. Now after this, I have to do oxygen balancing. Here I have 2 oxygens. Here I have 1 oxygen. So this side also 2 oxygens should be there. So MnO2 plus 4HCl gives rise to MnCl2 plus Cl2 plus 2H2O. So after doing that, this side also 2 oxygens, this side also 2 oxygens. Then after that, lastly, we have to check hydrogens. Here 2 2s are 4 hydrogens are there. Here also 4 hydrogens are there. That was balanced. Please note down this, children. We will do one more. Let us check out this in the oxidation number method, children. Here reactant side chlorine to product side 2 chlorine. So this is a disproportionation reaction. The same element is undergoing both oxidation and reduction. So the same is giving 2 different products. You already know that type of reaction. Here in the molecular form, chlorine oxidation state is 0, and in sodium chloride, you know, chlorine is -1, and here chlorine is +1, and here also change is 1, here also change is 1. This change you multiply with that one, and that change you multiply with this one. So what I am doing is Cl2 plus NaOH gives rise to NaCl plus NaOCl plus H2O. So if from here to here, if you multiply it with 1, you will get the same. Okay, from here to here you multiply with 1, you will get the same. Okay, after multiplication, now I want to balance the elements. So here 2 chlorine atoms are there. 1 plus 1, 2 chlorine atoms are there. It was balanced. Here I have 2 sodium. No? Here we have only 1 sodium. So I am repeating the step. 2 NaOH gives rise to NaCl plus NaOCl plus H2O, children. Now I am checking 2 chlorines done, 2 sodiums were done. Now I want to check the oxygens. Here I have 2 oxygens, and here 1 plus 1, 2 oxygens are already there. Oxygens are also balanced. Here I have 2 hydrogens, and here also I have 2 hydrogens. This was balanced, children. So we will do one more, and so that you will get some clarity. Dear children, this is looking a bit lengthier, but we have to follow the same procedure. So from manganese in the reactants to manganese in the products, I have mapped. Okay, and carbon in the reactants to carbon in the products, I have mapped. And the remaining terms, nothing to worry about that, and slowly we can balance everything out. So here oxidation state is 8 plus 7, and here oxidation state, so 4 power minus 2 plus 2 is the oxidation state. So here plus 7, here plus 2, children, the change is 5, right? So here carbon 8 1:6 plus 3, here oxidation state is plus 3 here, and here oxidation state is plus 4. The change for each carbon atom is 1, but here we have 2 carbon atoms, right? So change is 2 into 1, that is equals to 2. So the carbon change we have to multiply the manganese, and manganese change we have to multiply with the carbon. So now let us do 2KMnO4 plus 5H2C2O4. This we did not did anything, so it is like that only. And K2SO4 also we didn't touch it. So manganese terms 2 से multiply करो, right? 2MnSO4 plus carbon terms should be multiplied with 5. So after multiplying with 5, here 5 2s are 10 carbons are there now. If I multiply with 5, here I will have only 5 carbons, right? So I am multiplying with 10. So 10 CO2 plus H2O. Listen here carefully. Here also manganese 2. We have multiplied the manganese with 2, and here also manganese term with 2. That's right. And here the carbon terms, so we are multiplying with 5 no sir. Here also we have to multiply with 5. So I had told why I have multiplied with 10 clearly. So after multiplying with 5, 5 2s are how many carbons are there? 10 carbons. So this side also we should make the same number of carbon atoms. So I have taken like this. So we will cross check the remaining elements are balanced or not. So two potassiums balanced, two manganese were balanced, and carbons, two carbons, and two fives are 10 carbons, and here 10 carbons are balanced. So once we have to check the sulfurs, here we have one sulfur, here we have one sulfur and two sulfur. Two sulfurs are extra towards this side. Total how many sulfurs are there this side, children? 2 plus 1. 3 sulfurs are there. This side we have only one sulfur. So that side also multiply with 3. So I am writing 2KMnO4 plus 5H2C2O4 plus 3H2SO4 gives rise to K2SO4 plus 2MnSO4 plus 10CO2 plus H2. It is lengthier. So I have written H2O down. So by this the sulfurs are also balanced on both sides, right? After sulfurs balancing, all the elements were balanced. Now I am looking at the oxygens. Here 4 2s are 8 oxygens, 5 4s are 20 oxygens, 12 oxygens, 3 4s are 12 oxygens. Totally I have 40 oxygens towards this side, and here 4 oxygens plus 4 2s are 8 oxygens plus 20 oxygens. So this side we have here 32 oxygens are there. So don't bother about this water molecule. Here we have 32 oxygens. Here we have 40. That side 8 oxygens are less. So I am making that 2KMnO4 plus 5H2C2O4 plus 3H2SO4 gives rise to K2SO4 plus 2MnSO4 plus 10CO2. So 8H2O. So oxygens are also balanced. Now both sides 40 oxygens are there. Now whether hydrogens are balanced or not, let us cross check. So here we have 8 2s are 16 hydrogens, right? So here 5 2s are 10 plus 3 2s are 6. This side also 16 hydrogens are there, and this is balanced, children. See. Let us try out this one also, children, in oxidation number method. So I have mapped magnesium to magnesium in reactants and products, and nitrogen to this nitrogen in reactants and products. So elemental form oxidation state is 0. Here the oxidation state of manganese is plus 2, and HNO3 mein nitrogen is plus 5, and here it is plus 1. The change is 4 for each nitrogen, but here we have 2 nitrogens, no? So for 2 nitrogens the change is 8, and magnesium to magnesium the change is 2. So here I am simplifying, 2 1s are 2 4s are. Then multiply the change of nitrogen terms with manganese. change of manganese terms with nitrogen. So 4 Mg plus HNO3 gives rise to 4 Mg NO3 taken twice plus N2O plus H2O. So nitrogen terms are multiplied with 1 and manganese terms are multiplied with 4. So after that, children, now what you will have to do is, clearly once you check, children, so here manganese were balanced, 4 magnesiums are there. I have told after multiplying we have to make the elements both sides same, and here you can see, sir, after multiplying here 2 and here 1 only, no, that one only I am fixing now. Once clearly you see here 4 manganese and 4 manganese that were balanced, and here 2 fours are 8 nitrogens are there. So why was not fixed here only, sir? Why would not fix it at this step only? Because nitrogen is there in the both molecules, so we are doing in this method. So here 2 fours are 8 nitrogens are there plus 2. Totally 10 nitrogens are there. This side also 10 nitrogens should be there. You see 4 Mg plus 10 HNO3 gives rise to 4 Mg NO3 taken twice and N2O plus H2O. Okay, children. Now once you check, here 2 and 2 fours are 8. 8 plus 2, 10 nitrogens are there. Here also 10 nitrogens are there. 4 manganese. Elements were balanced. Now let us check the oxygens were balanced or not. 10 threes are 30 oxygens are there. 3 twos are 6, 4s are 24 oxygens plus 5, 25. And we need 5 more oxygens, right? So, and not calculate the oxygen of water because we have to balance based upon that. Here 1, here 6, 4s are 24 plus 1, 25. We need 5 more oxygens, right? So, 4 Mg plus 10 HNO3 gives rise to 4 Mg NO3 taken twice N2O4 plus 5 H2O. Now the oxygens are also fixed. So balanced on both sides. Here 30, 24, 25, 30, right? Now let us check whether the hydrogens are balanced or not. So here we have 5 twos are 10 hydrogens and we have 10 hydrogens here. So this is a clear explanation how to balance an equation by using oxidation number method. So now I will show you how the questions will be asked in JEE mains and NEET examinations based upon oxidation number method. Okay, children. Children, questions will be asked like this, and he will ask us to find out X, Y, Z in this following reaction after doing an oxidation number method. Now let us start here, children. Uranium to procedure is same only. Uranium to uranium and chromium to chromium. I have balanced. First let us find, yes, uranium is already given plus 2 oxidation state, and here the oxidation state is plus 6, and change in the uranium terms is 4, and chromium here 14 to 2 plus 6, and here chromium already given 3. For each chromium the change is 3, and how many such chromium atoms are there? 2 chromiums. 2 into 3, that is equal to 6. So the change in the chromium terms is 6, change in the uranium terms is 4. So I am simplifying, 2s are 3s are. Now what we have to do, we have to multiply with this 3 with uranium terms and this 2 with chromium terms. So this change we have to multiply with that one, and that change we have to multiply with this one. So chromium change is 3, right? So 3U2 plus and the chromium change is, sorry, uranium change is 2. So here 2Cr2O7 power minus 2 YH plus 3UO2 plus so uraniums are multiplied with 3, chromiums are multiplied with 2, no sir? Yes. Now if I multiply this with 2 Cr plus 3 plus BH2O, once see here we are getting 4 chromium atoms. Here we are getting only 2 chromium atoms. So here also I am making 4 chromium atoms. 4 Cr plus 3. That is the confusion. So we have already did 5. Similarly, we are doing this one. So after that, children, let us check whether all the elements are balanced. 3 uranium are there. So 4 chromiums are there balanced. So now we have to check the oxygens. Here 7 twos are 14 oxygens are there. Here already 6 oxygens are there. So 8 or less. So that side we will add 8. Cu plus 2 Cr2O7 power minus 2 YH plus gives rise to 3UO2 plus Cr plus 3, 6 plus 8 is equals to 14, 8H2O. So the thing is, we have to balance the hydrogens. Here we have 8 twos are 16 hydrogens. So why we have to make 16? 3U2 plus 2 Cr2O7 power minus 2. Okay, plus 16H plus gives rise to 3UO2 plus power plus 4 Cr plus 3 plus 8 H2O. Now all the terms are balanced. And what is the X in this reaction? 3 children. And what is the Y? Y is 16 children. And what is Z? Z is 4. So like this you can answer the question. Okay, we'll do one more question. See this one, children, you try at your end. So same procedure, but these are for JEE mains and advanced level. Pattern of questions will be like this. So now you start doing. So manganese to manganese mapped, carbon to carbon mapped. So now let us find the change in the oxidation state. Here the change in the oxidation, here oxidation to manganese is 7 plus 7 plus 2. The change in the manganese is 5 children. So carbon, here it is plus 3. Previously we did this method. So this is plus 4. The change is 1. But here 2 carbons. This side or this side. If you have 2 carbons, you have to multiply that. So 2 into change is 1 is 2. And manganese is only 5. So the change in the carbon term should be multiplied with the manganese. And the change in the manganese term should be multiplied with the carbon. So see, 2MnO4 minus 5C2O4 power minus 2. We don't know how many hydrogens are there. So 2Mn plus 2 plus, here is the actual confusion. So sir, carbon term should be multiplied with 5 now. So here 5CO2 you should write. Why you have written 10? Already we did no. So after multiplying, the number of elements both sides should be same. So here if you see, here if I write 5CO2 plus H2O, here the confusion starts actually. Here 5 twos are 10 carbons are there. So assume yourself, like imagine yourself multiplied. Multiply karne ke baad what we have to do? We have to balance. So you see 5 twos are 10. Here also should be 10. Na? So here I am writing 10 over 10 carbons that side, 10 carbons this side, the balance, right? Manganese 2 2, carbons 10 10, balance. Now I have to talk about oxygens. 5 fours are 20, 2 fours are 8, 28 are there. Here 20 are there, 10 twos are 8. Don't bother about this water. First check the oxygens. That side 28, this side 20, 8 more water needed. So 2MnO4 minus 5C2O4 power minus CH plus gives rise to 2Mn plus 2 plus 10CO2 plus 8H2O. Oxygens are balanced. After this, the last step is balancing hydrogens. 16 over there. Here we have to make it 16. 2MnO4 minus 5C2O4 power minus 2 plus 16H plus 2Mn plus 2 plus 10CO2 plus 8H2O. Now let us check that question. After balancing, what you want is A. A is what, children? 2, right? A is 2. And he need B. B is 5, children. And what more he need? C. C is 16. Like this, we can solve the problem. Okay. So let us look into the last question, which is like a different model. It is a reverse of disproportionation. It's a comproportionation reaction. So iodines, both iodines are going to give one product. So here molecular form, oxidation state of oxygen. Sorry, iodine is 0. And here it is plus 5. Here it is minus 1. So the change in the above one is 1. The change in the below one is 5. So multiply this change for this one and this change for this one. So it is iO3 minus 5I minus BH plus gives rise to CH2O. So what change we have to multiply towards that side, sir? So we have 5 iodines are there. Here 1 iodine is there. Total 6 iodines. That side also we have to have 6 iodines, right? 6I2. So now iodines were balanced and 3 oxygens are there. That side also should be 3. So I am taking 3 water molecules. iO3 minus 5I minus plus BH plus gives rise to 3H2O. That was done. Oxygens are fixed. And hydrogens, 3 to the 6 hydrogens. I have to fix the hydrogens towards the reactant side. 6 hydrogens, 3H2O plus 6I2. Now let us go into the question. He's asking what is A? A. A is 5. He's asking what is B? B is 6. So asking what is C? C is 3. D is 6. This is a complete descriptive video to balance an equation in oxidation number method. Hope you understood. Thank you very much for watching our video. Thank you.